So this is the Goal 6 lab write-up. This is going to be types of chemical reactions. And I am Mrs. Otri, and that is?
Nick.
Okay. So we're going to start off with the first type of reaction, which is a synthesis. They all know I have a speech impediment. We've gone through this all week today. And we're going to burn some magnesium. But we are missing something, Nick.
Yeah,
You see what we're missing? Yes.
Yep.
Magnesium is a metal, very nice, and unfortunately to put magnesium into the fire with your bare hands would be a bad idea. Putting magnesium in a fire without being a trained professional,
oh yeah,
it's a bad idea. All right, Nick, burn it. Do not look at the light.
That was weak.
Man, I never had anybody complain about magnesium being weak. So here what we did is we took the magnesium metal and we combined it with the oxygen in the air, okay, and we made this little ashy substance here. Let me move the Bunsen burner. And this is your magnesium oxide. So that's the compound we made. And that's the reaction for station 1. Alright, so this is station 2 reaction. Station 2 is a decomposition. And we are taking copper 2 sulfate pentahydrate, which means it's surrounded by water molecules. There's the formula for it right there. And we are going to decompose this substance. It's very pretty. It actually looks like little pebbles you would find in an aquarium, okay? But that is the hydrate. Very nice looking. So what we're going to do, it's actually not very exciting at all, unfortunately. I'm not supposed to say that. Make sure you edit that part out.
No, we'll leave it in.
Okay, so I'm going to take one of these lovely little crystals. I'm going to put it into a crucible, which looks cracked on the outside. All right, and then what I'm going to do is I'm going to heat this crucible up. Oops. I might even cover it up. So it's going to cook a little bit. And a little bit. A little bit. Oh, that's Miss Durkin. Miss Durkin, say hi. Hi. That's right. We torture more than just Nick here.
Yep.
All right, let's see. Basically what we're going to be doing is breaking down the copper sulfate into its 2 parts, which would be just copper sulfate and water. So I don't know, I'm going to see any steam here. Not yet. Anything happening?
I can hear it. Sizzling.
If you look at it there, Miss Saget, you will see that it's actually starting to lose its pretty blue color.
Yes, it's quite lighter.
Yes, and that's what happens. What's going on is all the water is actually coming out and breaking apart. It's decomposing.
So we got some evaporation of the H2O going on?
Yeah, you really can't see the vapors as well here, but you can see it's definitely getting lighter. See that?
Yes.
See that? Great. And that's about it. So this is station 3's reaction, which is going to be a single displacement. So what we're going to be doing is taking zinc. Zinc is our single element here, and this is mossy zinc. You can see that it has irregular shape. It kind of looks like what moss might look like if you found it in the woods, hence the name for mossy zinc. Has a whitish tinge to it, but it's gray. And we're going to put that onto our watch glass. Nick is going to go ahead and work the acid. We're using hydrochloric acid. It's 5 molar. So its concentration is about 1/3 of stock solution. And it's pretty darn concentrated. So what does that mean? Don't play with it at home, children. All right, Nick, squirt some nitric acid on that zinc. Ooh, ah. Now, hopefully, the camera is catching the fumes.
Yes.
And the bubbles of the zinc. And what's happening here is zinc is actually replacing hydrogen. So we're seeing hydrogen come off as an element in its elemental form as a gas. Okay?
Yes, it smells.
It does. It does have an odor. And in fact, it's also hot. It's warm to touch in the bottom of it. Ooh, chemical reaction.
We'll
Okay?
have to take your word for it.
Yes. Ouch. Okay? And that's station 3. Right?
That's
Okay,
okay.
station 4. Station 4's reaction is a double displacement. So in this case, the cations from the two ionic compounds will switch places. We have here potassium iodide, and we have lead nitrate. So the idea is that the potassium and the lead will switch places and form a new product.
They're both liquid.
They're
state.
both, yes. They're both clear liquids. Lead nitrate can be a little bit cloudy, but the potassium iodide is clear, colorless, and cloudy-ish white. Okay? So what Nick and I are going to do now is go ahead and squirt some on here. You ready, Nick? 1, 2, 3, squirt! Oh, look at that. So we made yellow stuff. If you let it sit long enough, it'll start to look grainy, and you can kind of see right here on the ends that has that little grainy appearance, which would be some of the solid we formed. So we formed a colored complex, or a colored substance, which is the the lead iodide. I had to think there for a second. And that was station 4. Okay, this is station 5. Got caught there, Nick. All right, so station 5 is a acid-base reaction, which is actually a type of double displacement. So we're still working with two ionic compounds. The cations are going to switch. In this case, though, we're neutralizing an acid, which we're using hydrochloric acid, with the base, sodium hydroxide. So what I'm going to do actually is start off with putting a little bit of the sodium hydroxide on the watch glass. And as you can tell, it is clear and it's colorless. Okay. And then what I'm going to do, though, in order for us to see the reaction, we're going to add an indicator. This indicator is phenolphthalein. And you will see what will happen when I add it to the base. Look at that. Okay.
Your favorite color?
It's, no, I like a little darker purple than that. That's a little bit light.
Okay.
It's like a Barney purple.
You should wear purple.
You should start wearing purple.
Start wearing purple.
That's right. Don't get me singing. All right, now. Now what Nick's going to do is Nick's going to add the acid to this sodium hydroxide. Keep on adding. Oh, look what happens when he adds. It starts to do what?
Separate.
Separate and clear up, right? You can add some more. Go ahead, go ahead, go ahead. Because technically they're supposed to keep on adding acid until the color would leave. And that's how we know that we added enough and we neutralized it. We changed that acid and base into salt and water.
It's pretty impressive.
Oh yeah, it's magic.
All right. Must be chemistry.
Okay, so station 6, the last station in this lab, is the combustion of ethanol. So we have some lovely ethanol here. It's clear, colorless, but definitely has a nice odor. Everybody's familiar with ethanol. Okay, there we go. And then what we're going to do is we're going to set it on fire. That's right, ladies and gentlemen, fire. So right now what's happening is the ethanol is combusting and it will keep on burning until all the ethanol is gone. But it's not just burning the ethanol. It's actually including, again, oxygen, which is in the air, and that's what fire needs to burn, okay? When this is all done, as it's going on, it's making, believe it or not, carbon dioxide and water. Combustion. Good stuff.